Okay, so hello everyone. I already gave the small disclaimer and the small presentation before starting the recording, so I think we can go on. So this is the small workshop for open source licensing on open source software. Okay, and I'm Xavier Salazar, the strategy and innovation officer at the ECI Foundation, and dealing with exploitation and sustainability matters within Syscale project. So I will provide at the beginning a small introduction, and then I will enter into the main principles of software licensing and specifically into open source software licensing. And then I will provide some examples on how we tackled all the licensing matters within Syscale project. And then I will finish with a small discussion on the sustainability and small conclusions out of those. Okay, so I always like I always start giving such a presentation, like presenting like different types of open. So there are many open stuff that is often misunderstood or mixed, or people think they are the same, but they are not. Okay, so we usually start, or there has been this big push towards getting open science and getting the science open to everyone. And there is often the confusion or the relation between open source and open science, which they are obviously related, but they are not the same. Okay, and the same with open innovation, open access, and even the difference between open and free. Okay, so open science refers to the practice of making scientific research and all the related data and tools and everything around accessible and available for everyone. Okay, and that has been a strong push over the last years, and especially within Horizon Europe and European Commission projects, like research that is paid by the public and by the contributor. It should be open and it should be used for it cannot be used for like the commercial yeah, well, it should be made as open as possible. Okay, open innovation. So it was a concept that was introduced by Henry Chesbrough, and it complements the open science. So it's like all the collaborative approach that enables like innovation to get out of company, project, or whatever, and to reach out society, okay, by bringing external ideas or technologies and expertise to the core or of the company or the project or whatever. So in a way, the Horizon Europe projects are a way of open innovating, okay, and with the conception that you need to create a consortia with different partners that are that need to collaborate and bring together like knowledge and expertise. Open access is like a brother of open science, or it's one of the main ways to implement open science. So it's like any research output to make it openly accessible for the rest of researchers. Okay, and open source, so it's not directly related to open science, because it can also be related to any kind of software, even if it's not related to science. Okay, and it refers to the fact that it's the source code is open to the user of the source code. So it can be modified, it can be reused, or it can be recompiled, and it's a way to make the code reusable and make the code or make software like more accessible. This complements open science because many times there's software or research software that it's developed as part of the science and the scientific studies, but not necessarily means that if open sourcing software means that you will be doing open science, and vice versa, that if you are doing open science that you really need to use always open source software. Okay. So open science approach has been introduced into the European projects and into Horizon 2020, and within Horizon Europe is being like it's becoming mandatory. Okay, so it's very important to understand how we should be addressing. Okay, and specifically, there are a set of open science practices that are becoming like contractually mandatory per grant agreement. Okay, so the C-Scale project, so we are an Horizon 2020 project, and we also have some needs to comply with open science practices. Okay, so basically there is there will be within Horizon Europe the obligation to provide open access to scientific publications under like the different types of open access. Data needs to be managed into within a fair or following the FAIR principles, which means that they need to be findable, accessible, interoperable, and reusable. And this needs to be covered and demonstrated within a data management plan. Okay, and again, related to software, so it should be like under the principle as open as possible and as close as necessary, which means that as well, if software is developed as an output of a project, so whenever possible, should be made open. Okay, but if there is like some legitimate interest, or if there is some commercial interest to make it to keep it closed, as well, it's possible if it's justified. Okay. As the relation between open science and research software is in the fact that you need to provide as well the necessary tools and instruments that were needed to validate like the conclusions of the scientific publications, which means that if you develop like some use cases, some software, some workflows in order to create, to generate some results, you need to provide them and make them available so that anyone wanting to replicate the study can do it. Okay, and which means again, you do not necessarily need to provide the software in an open source way, which means you can also provide the executable or the whole environment to make it to be able to enable the validation of the results. But obviously, if you provide it in an open source way, it also enables like porting to different environments and to enrich like the future results of the scientific publication. Okay, and as well, in case of public emergency, the European Commission could also ask for getting access to the results of the projects, which means that if any software that is developed, if it's already under an open source license, then you can directly streamline all this process. So within Horizon Europe projects and European projects, so since there are many partners delivering different solutions and different bringing together different knowledges and technologies, one of the most effective ways to foster this collaboration is by providing the different software components by each of the partners on under open source. Okay, this eliminates a lot of burdens for the collaboration, and if possible to do it, it makes like the collaboration easier. Okay, it in general it promotes the transparency, the reproducibility, and the access to the result, and as well it facilitates the future uptake. I mean, if you provide the whole source code, anybody that wants to take the results and build from them, you make it easier for them. And as well, as I was telling before, so it aligns with the principles of open science. Okay, so before entering into the open source licensing itself, I also like to start explaining the difference between what's intellectual property and the intellectual property rights, which it's often misunderstood. Okay, so the intellectual property, it refers on the knowledge and the assets and the creations that are done within the project. So it can be anything that it's related, that has been developed. And as such, a software can be an intellectual property asset. Okay, whereas the intellectual property rights are the legal rights you associate to those components, okay, in order to protect the use or the reuse, or to be able to make or to state the conditions under which later on they can be reused. Okay, there are different ways of protecting the intellectual property. Okay, and de facto, any creation can be software, written work, engineering, drawings, or anything that it's written. De facto, it comes with a copyright. Okay, you don't need to put to explicify, but whenever you create something, you get the copyright for having created. Okay, there are other kinds of IPRs that require like some registration. Okay, so like and some acceptance, like the patents. Okay, so those are the technical innovation that you apply for a patent on a geographical area, or and you grant then a monopoly right for exploiting that patent in that geographical area and for the time frame depending on the regulations and the laws of that country, or the country issuing the patent. There are other kinds like database rights, design rights, trademarks, and also confidentiality and trade secrets are also understood as a way of protecting the intellectual property. When we come to software, so it can be protected in many ways. Okay, it can be used many different intellectual property rights. So starting from the copyright, so all the source code as a written product that you do, it's automatically protected by copyright. There is the um, the recommendation to use always the explicit notice of the copyright in whatever, in any software file and any written part of the code, so that to make it clear that well, who is the owner and which year was created, and well, the copyright notice, so that it becomes clear. Software, it is patentable, okay, but only under certain conditions. So it should be a computer implemented invention, which means it needs to have like a technical physical effect. Okay, so it cannot be only pure business or financial effect. Okay, it should have like some physical output or some methodology associated to it. Usually the difference between the copyright and the patent as well. So the patent is protecting the methodology to do something, whereas the copyright is protecting the way how is it written, or how is this methodology written in a code. So it's one implementation of the patent. Many times there are trademarks that can be associated to a software product. So like the typical logos that you can associate, they can also be protected and they can become also a valuable asset. Trade secret can be also very important, and source code can be protected via encryption methodologies, or software can also be shared or can be distributed as a binary or an executable, so without the need of sharing the source code. And any kind of know-how that it's supporting, like the generation of the software or even the usage of the software, can also be kept confidential and can be also be part of an agreement. So once we have an IP protected, it can be licensed. Okay, and licensing means granting the right to use of any kind of protected assets under some agreed terms and conditions. Okay, and there can be like different types of licenses that go from more restrictive to more open ways. Okay, and we think here I would like to focus on the one side. I will enter with the proprietary software license. I will and then I will go to the open source, and I will also explain a bit like the difference between the free of charge. Okay, because well, proprietary licenses are when you don't want to disclose or when you don't necessarily want to disclose the open source, the code. Okay, and you just want to release the software as a package, as a binary or executable, and then you can put any kind of terms, and it can be against payment. You can set any kind of limitation on the use and the sales and the redistribution. Okay, a specific type of proprietary, which is mixing the proprietary license and the open source license, is when you offer like a software free of charge, when you offer access to the software code, but you do it in a specific license that you can restrict the use and you can limit the use to certain conditions or geographic area or for non-commercial, for trial. Okay, and that's a specific case that it's like mixing, like both, like the proprietary and the open aspects. Okay, and then we come to the open source, that it's usually coming or being defined under some standard open source license that have been used like over many years, but there are many of them as well. So there are, at the end of the day, they are specific cases of free of charge licensing. Okay, those have the commonality that they need to provide the access to the source code. They are usually delivered as is, which means no the user of the code or of the software takes whatever is there without any kind of warranty or liability. And it provides the freedom to use, modify, and redistribute under certain conditions that are defined in the open source license. Okay. General proprietary software license can have like many different terms. Okay, and each of the terms is it can be negotiated, and it can be negotiable, and it can include scope. It can include like exclusivity, non-exclusivity, like limitation on the usage, the commercial, non-commercial, educational, limitation on the geographic area, specific markets, technologies. It can limit the number of installations, chairs, sub-licensing. It can limit what the user can do. So if it's a closed source, so it can also limit the reverse engineering, the compiling, modifying, and it can also include like some clauses on maintenance and support, warranties, liabilities, and as I was telling before, so it can be against so free or against payment. When it comes to software, open source software license, then many of those terms get of the proprietary terms are no longer available or needed because of opening the source code. Okay, but there are very important terms, which are like the ability or the permission to perform derivative works and adaptations to the original code, the attribution. Okay, so it's the obligation to keep the copyright notice and any kind of acknowledgement from the original authors of the code that was used. Then the copyleft attribution. So it's the obligation that any modification done to the code is kept under the same license. And then this leads to the importance of studying the compatibility between licenses. Okay, because if you try to mix like different pieces of code between different licenses, there could be like some obligations of changing the license between them, and sometimes there can be like some incompatibilities. Okay, so the most common types of open source software licenses, so they can be divided into big groups, like the permissive and the copyleft. So the permissive are sometimes are also called the academics, so the VSD, MIT, or Apache licenses. So they are the ones that are giving the freedom or the full freedom to modify the code and to redistribute any kind of derivative under any type of license that you decide, which means you can take any software component under this license, and then you can do whatever you want. You can close it, you can change the license, you can reuse it, you can mix it with your code, you can do almost whatever you think is necessary. The only obligation in most of the cases is that you need to keep the attribution. So you need to keep the acknowledgement notice and the reference and to the copyright of the authors of the code. Copyleft or reciprocal licenses, so that are the GPL license. So they were the ones that were created originally, like following the Linux movement, and they are the opposite. Like they deliver, or they aim to deliver the code open for the user, but they oblige that the user will keep the code under the same license, which means that if you started with a GPL, like any kind of modification to it, you need to keep the same license. You cannot like close it. You cannot. You need to keep it open. Okay, and it's a way to offer a code openly and protect it against any indiscriminate usage, because you can always so anyone that has been using and reusing this code will need to keep on sharing it in an open way and with the same license. So it's a way as well to protect it. And then there's the strong copyleft, that it's like any kind of derivative must keep the same license rights, which means that it can viralize like the GPL. And then there are the lesser copyleft, which only sets the obligation to keep the same license right on the original code. Okay, so the permissive licenses, as I was explaining, so they give full freedom to use, minimal obligations. They are full compatible and very flexible. So they are usually used when you want to promote or widely promote like the use of one code among community and generate like a community around, and which would include as well companies or industrial players that will want to further explore and further exploit the software. Whereas the copyleft licenses, so they have all these obligations on keeping this well, the same license rights, which means that it could make that some softwares are not compatible. Okay, so they cannot be used together, and it can also make that if you bring together like different pieces of software into one program, that it obliges like the rest of the program to become GPL, as well as derivative of the original GPL code. So you usually need to be careful with this, because it could so if especially if for industrial people or companies, so if you are making business, or if you are having like some closed part of a code, you need to be very careful not to mix it with open GPL open source licenses, because it could oblige you to open like the rest of secret parts of the code. Okay, so here's summary table of what can be done, and the compatibilities of between the different types of licenses, and as well this was almost everything was covered before, so I don't think it's needed to get into the detail, but you have this as a reference. The only point maybe is the compatibility between patents. So as I was explaining at the beginning, so you can patent a method that it can be implemented via a software implementation. Okay, and there are some open source licenses that grant as well protection from any future patent claim that would try to sue you out of by having like a shared, like a software component under like this license. Which means as well that you can also think in patenting before or to patent the methodology, and later on as well open source like the software that is implementing the patent, so that you get the double protection at the end of the day. So you get the protection on the methodology that was used by this software, and as well on the actual implementation. Okay, and that's also a good way for protecting the result. And then for assessing the license compatibility within the European Commission, there has been this join up licensing assistant website created, where you can find all the different kind of, well, not all, but many of the typical software licenses that are available on the market. And then you can study, like you can think what are your needs. Okay, if you need to use patents, if you want to modify, if you want to distribute license, you can set the conditions that you want to follow, and then it will refer to the right license that or to the best or the most suitable licenses in order to cover your needs. Okay, so that's some recommendation to use. And then we go to some examples of how we have been using the open source licenses within C-Scale. And yeah, mainly the software, or most of the software that has been generated has been under the workflows solutions. Okay, and here I wanted to show some examples. So on the one side, we have been sharing the software under the GitHub, and within GitHub you can directly post like the license that you need. Okay, and for most of the workflows, so we wanted to foster like the uptake or the future uptake and the future reuse or adopt it or readopt it or redeploy all the solutions into different environments. Okay, so the most suitable or one of the most suitable licensing options was an Apache 2.0 license that it's like very flexible and very permissive. Okay, so this was used under the Aqua Monitor, and it would not compromise like other components within the workflow itself and the software generated. Another example was using the same approach, so under Apache 2.0 license. So this also permitted to port it into HPC environments and into like different environments, and as said that it is a very flexible way to share like the results or the software as a result, so that later on can be reused by anyone or by us. Third example as well, and following the same idea, so is the HiC, and here I wanted to as well use this example because one of the components or the subcomponents of this workflow is a component that while being also offered under an open source license, the owner of the component is offering like some support service against payment, like they offer like some commercial service packages, okay, that enable like monetization of the component itself. And well, it's a way to show like even if you are like having like open source solutions, so there can be ways for exploiting them for generating revenues. Okay, and that was one of the approaches that we had in one of the use cases. And finally, so we have the tutorials, okay, that the previous tutorials that were based like in generating some examples on usage of some specific technologies. And then the license that was selected for that was a strong copyleft license that given the nature of these components that are usually used as part of a server or that are used that can be used in the cloud. So that there was the selection of this Affero GPL, which enables like getting like it's not only the fact that you need to have the software available on a repository, but the fact that once it is uploaded on a server, you also need, so it should also be available from the server so that people can access the source code from there. And as well, it's a way to foster the usage and of to make it as accessible as possible to anyone. Okay, and as well, like to make users understand, like since those software components might be executed and might end up being executed within the servers, as well might enable the users to understand what is happening, okay, and as well to download, port it to their own servers and to reuse them, but as well under the limitation that they should also keep this Affero approach, okay, because it's a copyleft. So following the examples, I wanted to finish like this presentation on this to discuss a bit like on the sustainability of open source software, because there's the matter of fact that okay, when you have an open source project or open source software, you need to manage. So it's not only the fact that you put it on a repository and you make it available to anyone, but you want to create a community around, and you want to create like some you need to maintain it, and you need to engage people, and you need to support. So if you want open source software to be successfully managed, then you need to think in how to cover those costs associated, and it can come can be like all those that I was mentioning, like the maintenance, the support, the management, the engagement, and also the infrastructure and the hosting. And usually, and as this is the case in Syscale, so these initial costs are covered by a project or by an initiative, but then at some point once the project is finishing. So partners need to plan how to cover those costs, or how will those activities be covered after the project funding ends. Okay, so related to this, it is usually good to think about potential revenue streams. So which could be potential business models that can also bring some monetization. I was showing one of the examples before in the HiC project. So it can be provided with by providing support and maintenance against payment. I mean, it can be subscription, it can be a service contract, it can be a contract service package, or like whatever way of paying for the support. And it's one of the most often ways to monetize open source. Another typical way is by doing consulting by integrating, adapting, deploying open source software into the customer systems. Other ways is via dual licensing, which means you can open source license under a restrictive way or under a limited way, while keeping some commercial licensing terms that would include like other commercial types of clauses within the license that would enable as well monetization, which means open source license doesn't cover like any kind of warranties, any kind of liabilities. It doesn't cover like maintenance support, written above as well. So all this can be covered by a commercial license. So it can be offered as a service, so software as a service or platform as a service, which happens often in cloud solutions as the world that we are in C-scale. And it can be like some access enabled for user via payment or subscription, or via pay for access. And well, the external funding, so governmental funding, crowdfunding, donations. A bit of conclusions. Making open source software available under open source licenses maximizes the chances for their uptake, especially when we are within Horizon Europe projects. Okay, that so it helps to bring together the collaborations between the different partners and bring clarity on who did what, and bring clarity on how the outputs can be used in the end. Okay. Nevertheless, it is necessary to think about what is the most appropriate license, depending on if you need to monetize, if you need to encourage the as more wide usage as possible. Okay. And yeah, I wanted as well to cover like how these cost structures and revenue models have been also been covered in different ways, as I was so the different ways that I was explaining before, like within C-scale project, they have been also being considered in many ways. So the infrastructure and hosting, so the codes will be available under GitHub platform, and the infrastructure access and all the related support and technologies and tools are available under some of the defined services of the project. Support, including training activities, are available and will be made available from the project wiki. Maintenance, including software updates and bug fixing, it will depend on the future needs and the reuse, or how the components or the different components are being reused, and then all this will bring to the necessary modifications. And then the different costs for management and engagement so are covered at the moment under follow-up projects and by the partners that are covering them. As for revenue models, as well, we keep on this on-demand approach, and some specific components, as I was showing, they have like some specific contract, and we offer like the platform as a service, and within it there is the use against payment considered, and obviously we also rely on the follow-up projects and internal funding from the key partners that are supporting the projects. So I think we have like 10 minutes. So that was the presentation. If you have any questions, comments, considerations or remarks that you would like to offer. I don't have access to the chat,
I'm
maybe
looking
you
at
can.
the chat.
Yeah,
I'm looking at the chat. There is nothing at the chat at the moment. I don't know if people have questions. You can raise your hand or directly open your mic and camera and ask questions. Benjamin?
Yeah, thank you very much, Xavi. I have a question considering the IPRs. Could you go back to the slide?
Yep. This one or this one?
This one, actually.
Yeah.
So if you think about like a startup business, what kind of considerations would you personally make first when thinking about intellectual property and intellectual property rights? So how would I, because let's say I have a business secret, right? Or a piece of software that I want to protect. So which steps would you take first to protect actually that piece of information or that intellectual property? Because I want to sell it as well, right? So
yep. So that's a very wide question in the sense that it depends a lot on the type of software that you have. So how easy or difficult to replicate would it be? How the technical effect is created as part of the software. Okay, so if it is patentable or not. Okay, and as well on how do you expect to engage the user, the customers of the software. And I say customers because I say like who would pay for it. Okay, and then it depends a lot. Like if you want to put it as a service, or if you want to put it as a package or as a consulting service, then you might get the decision to keep it secret, to keep it encrypted, and to keep it as a binary, especially if it is easily replicable. Okay, so if it's some component that could be like reworked, rewritten, re-engineered easily, so it makes sense to keep the secret. On the other side, if you want to make a community, gain number of users, get like some user group to start testing, and then to grow it around, so you might prefer to get like an open source route, okay, and then build whatever services around, like I was explaining in the example, like if the know-how linked to the software is complex enough, you can easily make the software open source, but then deliver all kind of support services, trainings, consulting around as well, and make it against payment, because it is difficult enough so that people would need you even if you deliver the software. But as said, it depends a lot on the type of business. So you normally need to work it out together, like how you protect, or the protection strategies together with how you expect to sell it. As well, there is a key decision to be made at the beginning, that it's if you want to patent the
But
method
patent is
associated.
usually very expensive, right? So
it can be very expensive, but it can be also very valuable if you want to generate a company, or if you, because it's an asset that it's that can have a lot of value for investors. So when you go to an investor to ask for funding or to venture capital, or so, one of the first things that they ask you is, so what are your assets and how are they protected? And then if you only have secrets and you only have well, it might be seen. So if you have some tangible, some IP protected, well, some patent, you already have like some very tangible asset that you can really sell, and that you have like some granted monopoly for using it. So if it has like commercial potential, then you get like some competitive advantage just for having it. But that's as well a business decision, or it's a decision you need to do it from the beginning, okay? Because once you disclose it, so once you open source and once you disclose the method or any kind of documentation associated, then it could prevent a patent to be done, because it's one of the preconditions that it needs to be novel. So if you publish it, then no patent is possible. And that's as well one of the first decisions to be made.
Okay, thank you very much. I think it's 12 o'clock, but we have room for one more question, and then we need to leave the room because it's being used by other people. But then Anne wrote something in the chat. Anne, would you like to speak up, or should I read your question out loud?
I mean, oops, I can speak up if you want. I was asking about, you mentioned the community aspect, and when you have a community and you have a software, usually it's not really open in terms of roadmap. This is still the same people keeping the roadmap, and it's not always open. So how do you go from this open software to a really open, in the sense of non-focus, where people can also contribute financially and can sustain the software? I don't see any equivalent in Europe. And as you know, you seem to be very knowledgeable.
So first, maybe a clarification on the open concept. So code will be open anyway, in the sense that the access to the source code will be available regardless if there is a community that is supporting or that is deciding what to include and what not to include. Okay, so what it might be controlled is what changes or what modifications get into the code and which ones are not dismissed. And in this way, so big open source communities are becoming some sort of de facto standards, or the de facto standardization bodies that there is like some body behind, like some foundation or some group that are following like some conditions or some defined charter of
governance, maybe, right?
yeah, and that they decide like how the software should be managed. Okay, and then this software keeps on being open source. Okay, but it's just that you need to follow a process. Okay, this has some advantages and some disadvantages. So as you said, like not everything might become like a part of the software. So not all the modifications will be accepted, which means that it is somehow limiting to all the contributions. But on the other side, it ensures that the contributions that are made, so they have like the right quality, that they go in the right direction, and that would be, well, the typical examples of all the Linux distributions, and like that they have like the big communities, but they have the big rules, like what is accepted and what is not. Okay, how the disadvantages of having like a free way is that then you might end up having so many forks and so many different distributions that then software can become somewhat unmanageable or incompatible, or like too spread. And then when building a community, and when I say that it is recommendable to have some management, so it's basically this, like to have like some way to be able to update it, and to have like some roadmap and some general lines. Said this, it doesn't preclude that if you as a user want to take it, you can also modify, and you can also share it without becoming part of the common project. Okay, so you can also modify any kind of Linux distribution and adapt it to whatever driver or whatever needs that you have, and it will be your development and not necessarily become part of the general development of the solution. Okay, so said this, how to foster all this adoption. If you share the so if you use a permissive open source license, you make it as flexible as possible for users to do whatever they want, and then in a way you are like fostering the adoption and the usage. This doesn't mean that you will get some return out of this, but if what you want is to create or to foster the usage and get like as much adoption as possible, so you should think in the most permissive way as possible. Not sure if I covered the whole sentence, because the whole question, because it's as well, it's very wide, and it.
No, but thank you. Yeah, that was clarifying a few things, and like the governance, as mentioned by Sebastian, I think is probably one key part.
Yeah, completely.
Right. So I think I'll stop recording now. First,